should have their Chapter 4 review torn out and on their desks. Pencils and erasers should be put completely away in pencil bags, not just in the openings of desks, all the way in pencil bags. So is it in your pencil bag? Should not be in the opening of your desk. Make sure all pencils, erasers are all the way put away in your pencil bag. Only your red pen should be out of your pencil bag. Okay, Cullen, did you find a pen to use? Okay, so on the first page, we had vocabulary. First, you had to write the word that goes in the blank. Then you had to find it in the words in the word search. So, I had to put everybody back. Number 1. The answer or result of a multiplication problem is the what, Smith?
Estimate.
Not the estimate. It says the answer.
Oh, product.
Product. Good. So number 1 is product. The answer or result of a multiplication problem is the product. And you can find product right here in your word search. So make sure you have both of those. Number 2, a blank is a number close to an exact value. Michaela. An estimate. Remember, the product is the actual answer. The estimate is the answer that is close, but not exactly the actual answer. Yes, Zadie.
If we answer the question, since we found it in the word search, do you want us to tell you what row it's on?
No, that's okay, because I'll just show you, because that would just be easier. In the past, I'd have you guys come up and actually circle it, but because of COVID and everything, we can't do that. And if I call it like Smith wouldn't be able to come and do that. So, estimate is right here in the word search. So make sure you have both. Number 3, a blank of a number is the product of that number and any whole number. Aaron. A multiple of a number. A multiple of a number is the product of that number and any whole number. And you can find multiple diagonally right here. Oops, hard to do this like this. So there's the word multiple in the word search. Okay, number 4. Colin, make sure I can see you. Number 4, to regroup. Oh, I just told you. To blank is to use place value to exchange equal amounts when renaming a number. Zadie. To blank is to use place value to exchange equal amounts when renaming a number. Regroup. To regroup is to use place value to exchange equal amounts when renaming a number. Remember, regroup, rename can help you. And regroup is, where is it? Upside down, right here. It is upside down. So make sure you have both of those things. Number 5, the blank combines multiplication and addition by multiplying each addend by the number and adding the products. Victoria. The distributive property. So make sure you have distributive and property. And make sure the first letters of both of those words are capitalized, because math properties and formulas and theorems are all proper. because sometimes they're named after people. So the distributive property. And you can find distributive property going all the way across right here. It goes all the way across the whole word search. Yes, Cullen, don't forget to unmute yourself.
Am I freezing up?
You're kind of like jerky, if that makes sense. But overall,
Okay.
you're okay.
Because, like, I can see Carla, Smith, and Zari on one side, and then you're in a little tiny box.
I'm in a little tiny box. Okay.
Yes, it would be. That means it may say your network bandwidth is low.
Okay. So
But
just
it doesn't say that.
it might have said that and then gone away. So just try your best, and if you need to, Cullen, you can watch the video later on YouTube. Because unfortunately, there's really
Okay.
nothing I can do about that. Okay, and don't forget, there you go, you got it. Okay, number 6. To use blank, find the product for the ones, tens, and so forth separately, and then add them together. Carla,
Partial products.
partial products. Very good. Very good. To use partial products, find the product for the ones, tens, and so forth separately, and then add them together. And you can find partial products backwards on the top line. Some of these words are backwards. What do they mean by and so forth? It says find the product of the ones, tens, and so forth separately. What do they mean by and so forth? Smith?
They mean that you can have hundreds, thousands, one millions,
Very good.
and
They mean sometimes you're not just going to have ones and tens, but you can still use partial products because you can find the product for the hundreds, thousands, 10,000s, 100,000s, and so forth all separately. Then you would add them all together. Yes, Zadie, quickly.
I didn't get the last 2 words we did because I spent like 30 minutes on it, so I had to go and move on.
And that's okay, but you just always have to remember to come back. Okay, number 7. A number that divides a whole number evenly is called a blank. It is also a number that is multiplied by another number. Mason. Factor. Factor. A number that divides a whole number evenly is called a factor. It is also a number that is multiplied by another number. And you can find factor going diagonally backwards right here. Okay, does everybody have the first page? Okay, any questions before we move on? Okay, helper number 1. Please sanitize, erase, sanitize. Okay, so the directions for numbers 8 and 9 say multiply. Use basic facts and patterns. So Zari, number 8, 4 times 90. When we're using basic facts and patterns, what's step 1?
Well, if we would write it.
We're using basic facts and patterns, so do we have to write it up and down?
No, we can just find. We would do 4 times 9.
So we would find the basic fact first. I'll make sure I can see you. We would find the basic fact first, which is what, Zari?
9 times 4.
So 4 times 9. And then the next step is to solve. What is 4 times 9, Zari?
36.
36. Now, are we done?
No.
No, a lot of you are stopping at this step. Make sure you're not stopping at this step because 4 times 9 is 36. 4 times 90 is not 36. Because what do we have to do next, Zari?
We still have to look back onto the 90 and we would place our 0 at the end of our problem.
So we count the zeros at the end of our factors. How many zeros do we have at the end of our factors, Zari?
1.
1. And what do we do with that 1 0?
We place it at the back of our problem.
Not our problem, but our Michaela? We put it at the end of our product. Because at the end of our problem may confuse us where to put it. So we put it at the end of our product. So that means, Zari, 4 times 90 is what?
360.
360. Very good. Yes, Cullen?
I found it where I can see y'all, where I can see all of y'all.
Okay, but I don't want you to look at that because then I'm tiny. And you guys don't need to see each other. That's just a distraction. So
I can't see them. I can only see you.
Okay, good. Then yes, that's where you need to be. Okay, number 9. 6 times 3,000. Cullen, what's the first thing we do? Oops. When we're using basic facts and patterns to solve a problem, what is the first thing we do, Cullen? Don't forget to unmute yourself.
You may have to ask her to unmute.
Yeah. Oh. Let's see. Can you unmute yourself, Cullen?
I think she tried to say I can't.
Here, I'm going to say ask to unmute, so you should get something that's like,
A rectangle, and it's going to say, would you like to mute or stay muted?
okay, Cullen, we'll come back to you later, okay? It was working earlier, so I don't know why it's not working now. Zadie, number 9, 6 times 3,000. What's the first thing we do? We find our basic fact, which is what?
6 times
6 times 3. What do we do next?
you solve it.
We solve it. 6 times 3 is 18. Loudly with confidence. 18. Now what do we do? Are we done?
No.
No, because what do we have to do next?
We have to go back to 3,000 and put our zeros at the end of our number.
Well, first, before we can put them at the end, what do we have to do? Before we can put our zeros at the end, what do we have to do? Michaela?
Count our zeros
We have to count the zeros where?
at the end
At the end
of our factor.
of our factors. So let's count them, Zadie.
1, 2, 3.
And what do we do with those 3 zeros at the end of our factors?
We put them at the end of our
Of our what?
product.
We put them at the end of our product. 1, 2, 3. Now the last step is to always check to see if we did what? What do we always need to make sure we do? Last step of any problem, no matter what.
See if you need a comma.
Put commas. How many digits? We put a comma every how many digits? 3. Loudly. 1, 2, 3. So that means 6 times 3,000 is
18,000.
18,000. Make sure you're being loud, sorry. Zadie. Okay, the directions for numbers 10 and 11 say estimate. Round to the greatest place value. Circle if the estimate is greater than or less than the actual product. Carla, number 10, 1,478 times 4. Which of the factors do we always round, Carla?
We will round the bigger number.
The bigger factor, which in this case is which number?
1,478.
Good. And 1,478 rounded to the greatest place value is what?
It's rounded to 1,000.
We round it to 1,000. Now we can just use basic facts and patterns. 1,000 times 4 is what, Carla?
4,000.
4,000. Very good. Now we have to tell if this estimated product is greater or less than what our actual product would be. When we estimate it, is our estimated factor greater than or less than our actual factor, Carla?
Less.
Less. So that means our estimated product is less than or greater than our actual product.
It's going to be less than.
Good. It's less than. Remember, if your estimated factor is less than your actual factor, that means your estimated product will be less than the actual product. It's a pattern. Okay, number 11, 5 times 6,225. Smith, which of those factors are we gonna round?
The larger factor.
Which is?
6,225.
And 6,225 rounded to the greatest place value is what, Smith?
6,000.
6,000. Now, using basic facts and patterns, 5 times 6,000 is what, Smith?
30,000.
30,000. Very good. Now, when we estimated our factor, is 6,000 less than or greater than our actual factor?
Less than.
Less than. So that means our estimated product is going to be less than or greater than our actual product.
Less than.
Less than. Very good. If our estimated factor was greater than our actual factor, what does that mean about the answer, about the product? If the estimated product is greater than the actual product, the estimated factor is greater than the actual factor, what does that mean about the estimated answer, the estimated product? Zari?
That our estimated answer will be bigger than our actual answer.
Good. Now, you did not have to solve these, the actual answers. So if you see these on your test, hint, hint, are you going to have to actually solve them? Do you have to solve the problems to figure out if the estimated product is greater than or less than the actual product? No, because you can just look at what you did to the factor. Okay, is everybody good on numbers 8 through 11? Okay. Okay, number 12 through 17, the directions say multiply, check for reasonableness. So if you forgot to check for reasonableness, go ahead and right next to this direction, say -6. Because you'll lose 6 points for not checking for reasonableness. Okay, number 12, 43 times 5. Victoria, how did you choose to check for reasonableness? Estimation, area model, distributive property, or partial products? Estimate. So that means we do it first. 43 times 5 is our actual problem. What is our estimated equation? 40 times 5. And using basic facts and patterns, we know 40 times 5 is what? 200. So that means our answer needs to be close to 200 to be reasonable. Okay, now let's solve step 1 when we're multiplying. What do we do? Multiply the ones, which means we're doing what small equation? 3 times 5. And 3 times 5 equals? 15. Can we put 15 in the ones place? Well, tell me the math way. What goes in the ones place? Is that the math way? What's the math way of saying that we bring it up or put it up?
We bring the tens.
We don't bring it.
We add.
Michaela? We regroup the 1 to which place? We regroup the 1 to the tens place. Good. Now step 2. We multiply the tens, which means we're doing what small problem? 4 times 5, which equals 20. Do we put 20 down here?
No, we put 21 because 20 plus 1 equals 21.
Well, tell me the math way. What do we have to do? Do we always do 20 plus 1 in step 2?
Now we take the regular number and then we add it to our part.
Good. So we multiply the tens. 5 times 4 equals 20. Then we add the regroup number. So 5 times 4 is 20. 20 plus 1 is 21. Now we can't put 21 in the tens place, but do we have a hundredths place to regroup to? No. So we can just go ahead and put the 2 in the hundredths place in our product. So, Victoria, 43 times 5 is 215. Is that reasonable to say that it's close to our estimate? Yes. Okay, number 13. Michaela, how did you choose to check for reasonableness? Estimation, which means we do that first. All the other ways, we do them after. So, 24 times 9 is our actual problem. What is our estimated problem? 20 times 9. And using basic facts and patterns, 20 times 9 is what?
18.
Not 18, that's 2 times 9. Is 2 times 9 going to give us the same answer as 20 times 9? If we take 9 and repeat it 2 times, are we going to get the same amount as if we took 9 and repeated it 20 times? No. 180. Don't forget about moving those zeros when you're doing basic facts and patterns. So that means our answer needs to be close to 180. Okay, now let's multiply. Step 1. Multiply the ones, which means we're doing what small equation?
4, 9 times
Which equals? 9 times 4 equals?
36.
36. Can we put 36 in the ones place? No. What stays in the ones place?
The 6.
The 6. And what do we do with that 3? Tell me the math way.
It gets regrouped over to the 10.
We regroup it to the tens place. Very good. Now step 2, Michaela.
Multiply with 10.
Multiply the tens, which means we're doing what small equation?
9 times 2.
9 times 2, which equals?
18.
18. But are we done?
No.
No, because what do we have to do?
Add the 30
Add the math way.
number.
The regroup number. Very good. So 9 times 2 is 18. 18 plus 3 is 21. Again, do we have a hundredths place to regroup that 2 to? No. So we can just put it in the hundredths place of our product. So 24 times 9 is what, Michaela?
216.
216. Is that somewhat close to 180?
It's pretty close.
It's pretty close. So we can say we're reasonable. That's why personally, if I have to check, I do typically like to do like area models or something because you get the exact answer, but I know sometimes you have a limited amount of time and estimation is the quickest. So that's why even if you're checking for reasonableness with estimation, you always need to go back and check. That means, okay, I'm done with my test, I'm going to go back and check. Okay, 43 times 5. Well, 3 times 5 is 15, which I have. 4 times 5 is 20, and then plus 1 is 21, which I do have. So do you see how I worked through the process, again, just in my head, and I matched it? That's what you should do when you check, is work through those steps again without erasing or writing, and just making sure that you put the right thing. Because sometimes our only mistake is that we accidentally got the basic fact wrong. And if we go back and check, okay, 3 times 5 is 15. Yes, I do have that. But like, what if I accidentally put that 3 times 5 was 8 because I accidentally added? Well, when I go back and I do 3 times 5 is 15, what was I doing? I put an 8. I was adding. It's a good thing I went back and checked and did the whole process again. So that's why you always check by redoing the problem in your head and matching it with your answer. Okay, number 14, 829 times 8. Mason, how did you choose to check for reasonableness? Estimation, which means we do that first. So our actual problem is 829 times 8. What's our estimated problem?
800 times 8.
800 times 8. And using basic facts and patterns, 800 times 8 is
1,600.
not 1,600. What's our basic fact here?
Wait, 6,400?
6,400. Because our basic fact is 8 times 8, which equals 64. How many zeros do we have at the end of our factors? 2. So we need to put how many at the end of our product? Which makes 6,400. So we know our answer needs to be close to this. Okay, step 1, Mason,
Multiply the 1.
which means we're doing 9 times 8. 9 times 8 is,
72.
but we can't put 72 in the ones place, so what stays in the ones place?
2.
2, and what happens to the 7?
We put the 7.
To the,
10th place.
to the tens place. Very good. Step 2,
Multiply the 10.
multiply the tens, which means we're doing 8 times 2, which equals, but are we done? Because what do we have to do now?
Add 7.
Add the
Add the
regroup number. So 8 times 2 is 16, plus 7 is,
23.
not, yes, 23. Sorry. Yes, you're correct. But we can't put 23 in the tens place. Which digit stays in the tens place?
That's 3.
The 3. And do we have a hundreds place to regroup to?
Yes.
Yes, so we have to regroup that 2 to the hundreds place. Now, step 3,
Multiply the 1.
multiply the hundreds, which means we're doing 8 times 8. 8 times 8 equals 64. Are we done? Do we put 64 down there? No, because what do we have to do?
Add 2.
Add the
Regroup number.
regroup number. 8 times 8 is 64, plus 2 is 66. Do we have a thousands place to regroup to? No, so we can go ahead and put our 6 in the hundreds place, and then go ahead and put our 6 in the thousands place. And what's the last thing we should always do? Place the commas every how many digits? 3. 1, 2, 3, 1, done. So 829 times 8 is what, Mason?
6,632.
6,632. Is that reasonably close to 6,400? Yeah, we can say yes. Okay, is everybody with us? Okay, number 15. Aaron, we have 724 times 7. How did you choose to check for reasonableness? Estimation. Our estimated problem will be, louder, I can't hear you. 700 times 7. And 700 times 7 using basic facts and patterns is what? 4,900. Good. Okay, now we're ready to solve. Step 1, multiply the ones. That means we're doing 7 times 4. 7 times 4 equals 28. Can we put the 28 in the ones place? So 8 stays in the ones place. What happens to the 2? We regroup it to the tens place. Step 2, we're doing 7 times 2. That equals 14. Are we done? Because what do we have to do? Add the regroup number. So 7 times 2 is 14, plus 2 is 16. We can put the 6 in the ones place, but what do we have to do with, I'm sorry, the 10, we can put the 6 in the tens place, but what do we have to do with the 1? To the, we regroup it to the hundreds. Step 3, multiply the hundreds. 7 times 7 is, but are we done? Because we have to add the regroup number. 7 times 7 is 49, plus 1 is 50. What should we always do last? Put a comma. 1, 2, 3, 1, and we're done. So 724 times 7 is 5,068. Is that reasonably close to our estimate of 4,900? Yeah, close enough. Okay, number 16, 569 times 6. Zari, how did you choose to check for reasonableness?
Estimation.
Estimation. So our estimated equation is
600 times 6.
600 times 6. Now, up until now, we've always rounded down. Our estimated factor has been less. But now, our estimated factor is more because our digit in the tens place is 5 or above. So don't just think, just because you haven't had to round up any other times, that you won't ever have to. Make sure that you check and go slow. Okay, Zari, 600 times 6 is what?
Do you want me to put in did you mean find the
The estimated, yes. Sorry, go ahead.
600 times 6, I broke it up to 6 times 6 to make it easier, and I got 36 for the 6 times 6, and then I knew I had to add 2 more zeros at the end.
Good.
And I placed my comma every 3 digits, so that would be in the middle of the 3 and the 6.
Mm-hmm. So 600 times 6 is
3,600.
3,600. Very good. Colin, make sure I can see you. Okay, Zari, now we need to solve. Step 1.
Multiply the ones.
Multiply the ones. 9 times 6 is
54.
54. But what do we have to do with the 5?
You would round the 5.
Not round, but
you regroup the 5 to the 6 in the tens place.
We regroup the 5 to the tens place. Okay, now step 2.
Multiply the tens.
Multiply the tens. 6 times 6 equals.
Is it okay if I do 6 times 6 plus 5?
No, I want you to we're going to go step by step. So the beginning of the step is 6 times 6 is
36.
36, but we have to add our regroup number. So 36 plus 5 is
41.
41. We put our 1 in the tens place. What happens to that 4?
You regroup it to the hundreds place.
Good.
And you would picture 4 and you would leave it.
Good. So now step 3.
Multiply the hundreds.
Multiply the hundreds. So 6 times 5 is you didn't unmute. You're still muted.
30.
30. But we have to add the regroup number. So 30 plus 4 is
34.
34. So 569 times 6 is
3,414.
good. Is that reasonably close to 3,600?
Yes.
Yeah. Very good. Do you notice how when we rounded this one up to 600, our estimated answer, 3,600, is greater than our actual answer, 3,414. And all the other times, our estimated answer was less. Because remember, when your estimated factor is less, your estimated product is less. Estimated factor is less, estimated product is less. Estimated factor is more, estimated product is more. So now you see that for real. Okay, Colin, number 17. Are you able to unmute?
Mhm.
Okay, there you go. So, which way did you choose to check for reasonableness?
Estimation.
Estimation. So 617 times 3, the estimated equation would be
600 times 3.
600 times 3. And using basic facts and patterns, 600 times 3 is
1,800.
1,800. Okay, now we're ready to solve. Step 1, Cullen.
Multiply the ones.
Multiply the 1. So we're doing 7 times 3. 7 times 3 equals what?
21.
21. Our 1 goes in the 1's place. What happens to the 2?
The 2 regroups to the 10.
The 2 regroups to the 10's place. Very good. Step 2.
Multiply the 10.
So we're doing 3 times 1, which equals?
3.
Then we have to
Add 2.
add 2. 3 plus 2 is?
5.
5. Do we have to regroup there?
No, ma'am.
Nope, we're good. So now step 3 is?
Multiply the hundreds.
Multiply the hundreds. 3 times 6 is?
3 times 6 is 18.
18, and we have no nothing to add. So that means 617 times 3 is?
1,851.
1,851. Very good. And we notice our estimated factor was less than our actual factor, and our estimated answer is less than our actual answer. Very good. Okay, everybody with us? Any questions before we move on to the word problems? Okay. Okay, so everybody, let's look at number 18. We might actually finish this before specials. It'll be the first time ever. Number
Specials.
18. Yes, quickly, Zari.
That was everyone picked exclamation for the
I figured, and that's fine. You got to choose, and I figured you would, and that's fine. Okay, number 18. Marcia read 2 books. Each book was 44 pages long. How many pages did she read? Well, let's first find all the important information. Aaron, what do we look for first when we have word problems? The question, which is what?
How many pages did she read?
How many pages did she read? What do we look for next? Our answer unit. Where do we find the answer unit?
After how many?
After how many? What word comes after how many?
Pages.
Pages. So that means our answer is going to be a number of pages. Is there anything else in that question that we need right now? No. So where do we go? Back to the we go back to the beginning of the problem. So now we have Marcia read 2 books. We have a number with a noun, but do we know if that's important yet? No. So we should go to the next sentence. And we have each book was 44 pages long. Ooh, I already know there's lots of important information here. What's the first thing that we're looking for that we need to mark? Okay, 44 pages. Why are we're putting that in a box? Why are we putting 44 pages in a box? Because our answer unit is pages, and we have a number before it. So we know that's going to be part of our equation or answer? Our equation. What else do I see in that sentence? Each. Each tells me what? I'm multiplying or dividing. Do I know exactly which one yet? No, but what do I know I can find next? What am I looking for after I find each? Or a word that means the same thing as each? What do I look for next? My other unit, which I find where? After each or after a word that means the same thing as each. So what's our other unit? Book. So now we're looking for a number of books. Do I have it yet? And I already know it's not in my question. Let's read our question. How many pages did she read? Do I find the other unit there?
No.
So I need to go back to the beginning. Marcia read 2 books. Did I find it there? Yes. What is it? 2 books, because I have my other unit, books, with a number before it. Now we need to figure out, do we multiply or divide, right? So if I have 2 books, and each one has 44 pages, am I going to end up with more or less of my answer unit, 44 pages? More. So that means I am multiplying. Okay? We've already found all the important information. Now it's just about writing the equation. When we multiply, does it matter which factor comes first? No. So what should our equation look like? 44 times 2. If you have 2 times 44, are you incorrect? No. Because of what? Smith?
The commutative property.
Of
Multiplication.
multiplication. The commutative property of multiplication. It doesn't matter what order our factors are in, we'll get the same answer. So now, Aaron, this is a word problem. We have to set this up and down, right? So where should you be looking now? Your separate sheet of paper. And on your separate sheet of paper, you should have number 18. And then you should have your problem, 44 times 2, written up and down. I will say, even though you can write your equation as 44 times 2 or 2 times 44, it is always most helpful to put the smaller factor on the bottom. So even if you have 2 times 44 written on your line, I would always set it up so that your smaller factor is on the bottom. Yes, Cullen. Gosh, this is going to be even harder.
It says you muted.
Okay, that might be just you. Can you hear me though? Okay, well just try your best, and if you need to, because girls, can the rest of you hear me?
Yes.
Okay.
Yes.
Maybe here and there there's a glitch, but that's just my internet.
Yeah, and you're out in the country too, Cullen, so it might be your internet too. Do you need me to mute you?
No, and we have like neighbors.
Okay, Aaron. So now let's solve. Step 1. Multiply the ones. 2 times 4 is? 8. Do we need to regroup? Nope. Step 2. Multiply the tens, which means we're doing 2 times 4. 2 times 4 is? 8. Do we have anything regrouped to add? Nope. So that means 44 times 2 is? 88. Which means, how many pages did she read, Aaron? 88 pages. Make sure you have your unit. If you do not have your unit or equation written, write it with your red pen. Okay, number 19. Tanya has 4 decks of 52 cards in each deck. How many cards does Tanya have? Zadie, what do we look for first when we have a word problem?
You look for the question.
The question. What is the question?
The question is, how many cards does Tiana have?
How many cards does Tanya have? Now, once we find the question, what do we look for next? Michaela? Which unit? The answer unit. Zadie, where do we find the answer unit? After how many, or after words that mean the same thing. Because if it says, what is the number of, does that mean the same thing as how many?
Yes.
Yes. So remember, sometimes you're going to see an answer, words that mean the same thing. Like you won't see how many, but you'll see what is the number of, which means the exact same thing. So what word, we have how many, what word comes after how many? Cards. So cards is our answer unit. Do we see anything else in this question that's important? No. So where do we go? Back to the beginning.
Really?
You're muted.
I'll mute her. Okay. So let's go back to the beginning. Tanya has 4 decks of 52 cards in each deck. Well, what do we know right away is important? Each. Okay, because each tells us
That we're multiplying or dividing.
that we're multiplying or dividing. What do we look for after each? The other unit. What is our other unit? Deck. Now, are we always going to see the word each?
No.
No, but sometimes we're going to see words that mean the same thing as each, like in a or per. Those mean the same thing as each. Whatever comes after in a or per is going to be our answer unit. What else do we see?
52 cards.
52 cards. Why do we know that's important?
Because our answer unit is cards.
Our answer unit is cards, and what comes right before it?
What comes right before cards is a number.
A number. So we know a number of cards is important. Is there anything else important in that sentence?
No.
Are you sure? How do we know the other part? We know one of the pieces of our equation, 52, but how do we know the other one? What do we have to look for?
Our other unit.
With a
No.
number before it. Do we see our other unit?
Yes.
Is there a number before it?
Yes.
Yes, because even though it's in word form, does that make it not a number anymore? No. So what's the other important piece of our problem?
4 decks.
4 decks. Okay, now we need to figure out, are we multiplying or dividing? Well, if we have 4 decks of cards and there's 52 in each box, are we going to end up with more or less of our answer unit cards than 52?
More.
More, which means we are
Multiply.
multiplying. So now what should our equation look like?
4 times 52.
4 times 52. Is it wrong if you put 52 times 4?
No.
No. So, can we solve that sideways like that?
No.
No. So where do we need to go to look?
So our separate.
Our separate sheet of paper, and you should have the number 19 with 4 times 52 written up and down. But remember, it's better to put the small factor on the bottom, especially if there are less digits. If there are the same amount of digits, it's not as big of a deal. But if there are less digits, you need to put the factor with less digits on the bottom. It's just going to make it way easier. Okay, so now we're ready to solve, right? Step 1, Zadie.
Multiply the ones.
Multiply the 1. So 2 times 4 is?
8.
Do we have anything to regroup? Nope, so we can move on to step 2, which is?
Multiply the 10.
Multiply the 10s. 4 times 5 is?
20.
20. We have something to regroup, but do we have a hundredths place to regroup to in our factors? No. So we can just put it in the product, in the hundredths place of the product. So that means 52 times 4 is?
208.
208, which means how many cards does Tanya have, Zadie?
208. And what I also did.
208 what?
208 cards.
208 cards. We still have 10 minutes. We may be able to do this. We may not. Oh, I spoke too soon. I jinxed it.
And what I did is I wrote the regrouped numbers since we have a place for it. I wrote it smaller so I know it's not part of 52,
Okay.
but beside it.
Ah, okay. Okay, so that means you should have 4 times 52 equals 208 cards on your line, and you should have this on your extra sheet of paper. Okay, Michaela, you're going to help me with number 20. It says, each ski pass costs $109. How much do 5 ski passes cost? Well, what do we need to find first? Anytime we're doing word problems, we look for the what first?
Question.
The question, which is what?
How much do 5 ski passes cost?
How much do 5 ski passes cost? After we find the question, we always look for the, which unit?
Our answer.
The answer unit. Now I see how much, but I don't see a noun right after. But I know if I have seen money earlier, then how much means what's our unit? A dollar sign, because how much money do 5 ski passes cost means the same thing as how much do 5 ski passes cost. So a dollar sign or money is our answer unit. I see a number with a noun after, 5 ski passes, but do I know 100% if that's important yet? No. So where should I go back to? The beginning. And now I read, each ski pass costs $109. Well, what do I see? Each. What does each mean?
It means you're multiplying or dividing.
I'm multiplying or dividing, and then after each, or a word that means the same thing as each, what comes next?
Your other unit.
My other unit. So what's my other unit?
Ski.
Not just ski, but ski pass. Good, because sometimes it is a 2-word noun. So ski pass is our other unit. Is there anything else important in this problem? In this sentence?
Yes.
What?
$109.
$109, because I see my answer unit, that dollar sign for money, and I see a number with it, so I know that's part of my equation or my product?
Your product. Your equation.
Equation, good. Do I have the other piece yet?
No.
No, so I need to go ahead and
Keep reading.
keep reading. How much do 5 ski passes cost? Do I see something important there?
Yes.
What do I see?
5 ski
5 ski passes. I see my other unit, ski passes, with a number before it, 5. Is there anything else?
passes. No.
No. So now I'm ready to write my equation. What does my equation look like?
109 times 5.
$109. Don't forget, if there's dollars, you include it in the equation. $109 times 5. Michaela, if I'd written that 5 times $109, would I be wrong?
No.
No. And now, do I solve it like this?
No.
So where do I need to go? To my separate sheet, where I should have number 20 and $109 times 5 written up and down. Okay, Michaela, step 1.
Multiply the 1.
Multiply the ones. 9 times 5 equals
45.
45. Good. What happens with that 4 though?
It gets regrouped to the next.
We regroup it to the tens place. Step 2.
Multiply the 10.
Multiply the tens. 5 times 0 is,
0.
but then I have to
Add your 4.
add my 4. 5 times 0 is 0, plus 4 is
4.
4. Very good. Step 3.
Multiply your hundreds.
Multiply the hundredths. I have 5 times 1, which equals,
5.
what should I do last?
Add your dollar sign.
Add my dollar sign. So $109 times $5 is
$545.
$545, which means how much do 5 ski passes cost?
$545.
540, whoops. $545. There you go. I think we have 5 minutes.
You're muted.
I'm muted. Oh, Colin. Okay, I'll mute her.
No, you are.
I've got you, Colin. Oh, she did it. She's getting the hang of it. So number 21. A kangaroo can jump as far as 44 feet in a single jump. What distance would 3 jumps of this size cover? Explain how to use the distributive property to solve. So, Zari, you're going to help me with this. When it says explain how to use the distributive property to solve, you could have just used, as long as you use the distributive property, then you did that. So, Zari, first we have a word problem, so we need to find the question. What is the question? Mason, pay attention.
What distance would 3 jumps of this size cover?
What distance would 3 jumps of this size cover? Now, Zari, I don't see how many or how much, or even what is the number of. But I do see what distance. What distance tells me that my answer unit, the distance, tells me my answer unit is going to be a unit of measurement for distance. So I know I'm looking for a number with a unit of measurement for distance. Do I see it in this question yet?
No.
No. I also see 3 jumps, but do I know if that's important yet?
No, because we have not seen each yet.
Good. So now let's go back to the beginning. A kangaroo can jump as far as 44 feet in a single jump. What do I see?
44 feet, because that's a length of measurement.
Good, because I have a number 44 followed by a unit of measurement. I know my answer unit has to be distance, which means 44 feet. Since feet is a unit of measurement for distance, I know 44 feet is important. I don't see each though. But I know each means how many. If I have the word each, how many do I have? Like if I had each shrimp I ate was delicious. I'm talking about how many shrimp at one time.
More than one.
Not more than one.
One at a time.
One at a time. If I say each shrimp was delicious, that means I ate one shrimp at a time. Do you see a word that means the same thing as one, Zari? Oops. Do you see a word that means the same thing as one in that sentence? You're still muted.
What distance?
Not what distance. We're just looking at the sentence. A kangaroo can jump as far as 44 feet in a single jump. Which of those words means the same thing as one? Zari?
What 3 jumps?
Not. Zari, listen. We're only looking at the sentence. A kangaroo can jump as far as 44 feet in a single jump. Which of those words means the same thing as one? Zadie? Single. So single means one. There's our word that means the same thing as each. Remember, if you don't see how many, you look for words that mean the same thing. If you don't see each, you look for words that mean the same thing as one. So single means the same thing as one, which means we are multiplying or dividing. What word? We're still going to follow that same pattern where we look for the rule after the word that means the same thing as each, which is what, Zari?
Jump.
So that means jump is our
Other unit.
good. And in our question, we saw what distance would 3 jumps of this size cover. Is there something important there?
Yes.
What is it?
3 jumps.
3 jumps. So we know our equation looks like what, Zari?
44 times 3.
44 times 3, or 3 times 44. Can we solve it that way?
No.
No. So we need to come to our separate sheet of paper. But are we solving it up and down?
No.
No, we're solving it in in distributive property. So we do go ahead and rewrite the problem. 44 times 3 equals. But now what do we need to do first? We need to write 44 we need to decompose 44 into what?
Expanded form.
Expanded form. 44 in expanded form is
40 plus 4.
40 plus 4. Now we need to multiply our small factor by each of these add-ins. So what does our equation look like, Zari? Don't forget to tell me symbols.
Parentheses 3 times 40 parentheses plus parentheses 4 times 3 parentheses.
Good, but remember, we try to keep our small factor in the same place so that we don't get confused. So 3 times 40, parentheses, 3 times 40, parentheses, plus parentheses, 3 times 4, parentheses. Now, we're ready to solve. We solve each multiplication problem and we bring down the plus sign. Which one should we solve first, the tens or the ones, Ari?
The tens.
The tens.
Yeah.
So 3 times 40 is
120.
120. We bring down our plus sign. Now we solve the ones. 3 times 4 is
12.
Now what do we do with those two partial products?
We add them together.
We add them together. Are we going to have to regroup anywhere, Zari?
No.
No. So 120 plus 12 equals
132.
132. So that means how far can a kangaroo, let's see, what distance with 3 jumps of this size cover? The answer is, Zari?
44 times 3 in distributive property, I found 132 distance.
But do we write distance?
No.
Because what is our unit of measurement that we found?
Feet.
Feet. So our answer is 132 feet. If you have distance, I'm not going to count it off, but do draw a red line through distance and write feet. Okay?
I just accidentally said that because I was looking at the word.
That's fine. Yes, Smith.
Is it okay if we wrote the abbreviation for feet?
That is fine. Let me text Miss Miller really quick.
Miss Solis,
Yes.
and I only have the code for this Zoom.
I realized that just a minute ago.
I can
Maybe,
give it to you. I
yeah.
know all of them.
Let's finish this so that we can get finished, and then you girls, you two, Zari and Cullen, you can stay behind, and Zari, you can chat it to her. But let's finish this first, okay? We only have 2 problems left. We can do it. Okay, number 22. There are 4 blue party bags and 4 red party bags. Each bag contains 12 items. Is it reasonable to say that the bags will have 75 items in all? Explain. So, Mason, you're going to help me out. We have to solve first. We have to figure out how many items there are going to be first, right? Before we can say if it's reasonable whether there's 75. If it asks, is it reasonable to say that the bags will have 75 items in all, you're comparing. But before we can find what to compare 75 to, we have to solve. So, we know there are 4 blue party bags and 4 red party bags. How many bags are how many items are in each bag? Mason? 12. Is there a different number of items in the blue party bags from the red party bags, or do they all have the same amount? They all have the same amount. So that means what we can do, we don't even have to do 4 times 12 and 4 times 12 and then add those answers together. We could just add the 2 party bags together and then multiply it by 12. So if there are 4 blue party bags and 4 red party bags, how many party bags are there altogether? 8. So that means we're taking 8 party bags and multiplying it by how many items? 12. So 8 party bags times 12 items. Can we solve that sideways like that? No. Not in this chapter. But next chapter, yes, because 8 times 12 is a what? Victoria? A basic fact. But since we're learning the steps, we're going to go ahead and solve it. Once we get to chapter 5, even if your final your final equation is a basic fact, you can just write the answer. But since we're practicing, we're going to go ahead and solve it up and down. So you should be on your extra sheet of paper. And we need to write our equation up and down. And now, Mason, we're ready to solve. Step 1. We got to get through this. Multiply the ones. 2 times 8 equals 16. We're going to put the 6 in the ones place, where we're going to regroup the 1 to the tens place. Step 2, Mason. Multiply the tens. 8 times 1 is
8
plus our regrouped 1. So that means 12 times 8 is what?
96.
Which means how many items are there in all?
96.
Unit?
96 party bags.
Not party bags. Are there 96 party bags in the 8 party bags?
No.
There's 96
Items.
items in the 8 party bags. Now, are we done?
No.
No, because we have to answer the question. Is it reasonable to say that the party bags will have 75 items in all? Well, is it? Is it reasonable to say that the party bags will have 75 items in all? No. Why? Now, usually I say you can't say no because, but in math you can. No, it is not reasonable because...
The
Who?
answer is 96.
Which is?
The item.
Well, what is 96 is what? Remember, when we say, is it reasonable that the bags will have 75 items in all? That means we're comparing. So it's not reasonable because 96 is greater because 96 is greater than 75. So when you say who made more, who had more, which one had more, or is it reasonable to say that they will have this number, that means you're comparing. Okay, let's get to the very last problem. And then we'll go number, what? Is it super quick or can it wait? Okay, what is it?
What if you wrote 4 times 12, 4 times 12?
That's fine. You still did it right. If you found 4 times 12 and 4 times 12 and then added the answers together, you're still right. But, so if you did 4 times 12 equals 48, and then 4 times 12 equals 48, and then 48 plus 48 is 96, that's fine, as long as you did all that. But just know, all you had to do was add the party bags together, which is a little quicker, but that's okay. That's okay. Okay, number 23. A plane carries 234 passengers. If the plane makes 4 trips a day, how many passengers does the plane transport a day? Cullen, we have to go real fast. So what is our equation? We know there's 234 passengers, and the plane takes 4 trips a day. So what is our equation that tells us how many passengers the plane will transport in a day?
Do the problem.
Yeah, what is the equation? Because we don't have time to go through. I wish we did, but...
The equation is 234 times 4.
Good. Because 234 passengers a flight, or a trip, times 4 trips will give us our answer. So Cullen, step 1.
Multiply the ones.
Multiply the ones. 4 times 4 equals
16.
16, but we have to regroup the 1 to the
10s.
tens place. Good. Step 2.
Multiply the 10s.
4 times 3 equals,
4 times 3 is 12.
plus our regrouped 1,
13.
13. We have to regroup the 1 to the
Hundreds.
hundreds. Step 3.
Multiply the hundreds.
Multiply the hundreds. 4 times 2 is,
4 times 2 is 8.
plus our regrouped 1.
9.
So that means our answer is, which letter?
1. B. D. Sorry. D. 936 passengers.
Very good. D, 936 passengers. Remember, if you're solving these and you get to a point and you're like, wait, that answer's not here. Does that mean you just pick the closest one? Does that mean you just pick the closest one? If you get an answer that's not here, do you just pick the closest one? No, what do you do? Zadie?
You rework your problem.
You rework your problem. Because if you get an answer and it's not here, that means you got it wrong. Okay, everybody, leave your stuff on your desk because we don't have time to put it away right now. Get out your reading logs, open them up, then line up in your order.
Bring out a book.
Yes,
Miss Flowers?
bring your books to read. Yes, Carla, quickly.
Send Colin the...
No, I'm doing that.
It's okay. Yes, Zari's going to do that. Please I've already said this. Zari and Cullen are going to stay behind. Zari is going to chat the information to Cullen, and then Cullen will meet you in library. So quickly leave your reading logs out on your desk. Grab your books, line up in your order. Smith and Carla, I'll see you after lunch at 12:30. Ready to keep working on Thanksgiving paragraphs. And then, yes, Cullen.